Hi, my name is Steve Buchanan. I have practiced endodontics as a specialty in Santa Barbara, California from 1980 to the present time. I'm an assistant clinical professor in USC's postgraduate endodontic department, a diplomate of the American Board of Endodontics, and I'm the founder of Dental Education Laboratories, a hands-on teaching facility in Santa Barbara. On this DVD for Engel's textbook, Endodontics, I'm going to review the concepts and techniques for using two-centered condensation methods for three-dimensionally obturating root canal systems. The first technique, the continuous wave of condensation, is done with a System B electric heat carrier manufactured by Cybron Endo. The second technique, carrier-based filling, is done with GT Obturators manufactured by Dentsply Tulsa Company. Both of these methods operate in the inverse manner of our three-part impression techniques, which explains the speed and efficacy of the filling results that they can achieve. In centered condensation methods, the impression tray function is provided by the electric heat plugger or carrier. The heavy-bodied impression material is replaced by thermosoftened gutta percha, and the light-bodied impression material in these endodontic methods is replaced with sealer. This is important to understand as the pluggers or carriers, like the impression tray, are not meant to fit the canal preparation tightly, but are meant to push the heavy-bodied gutta percha and the light-bodied sealer, which acts like a lubricant, through the root canal system. A cone is fit in the prepared canal. It's cut back a ½ millimeter short of full length. A plugger of the same taper is fit in the canal, pushed and wiggled. The canal will bend the plugger to its binding point. A stop is placed so we know where that binding point is, and we're ready to cement the cone. After the cone is cemented, it's going to be seared off at the orifice. We've pushed the high heat icon on the System B heat source. We're going to sear it off. We're going to condense the gutta percha at the orifice with the fat stainless steel end of the hand plugger. After that, we're going to bring the continuous wave plugger in cold first, push on it, hit the button. It'll immediately take off, and in a second and a half or 2 seconds, we'll be within 2 millimeters of the binding point. We hold a sustained condensation force with no heat. Then, after 5 seconds, at least 1 second of separation heat, pull the plugger out. You can see the surplus gutta percha attached to the plugger. Now we take the narrow nickel titanium end of the hand plugger in and condense the apical mass of gutta percha in preparation for the backfill. Here's the motor-driven inline extruder. We push the forward part of the toggle to prime the needle. Now the gutta percha is to the end of the needle. We put it in the canal, wait 5 seconds to heat the canal with the needle, and push the back end of the toggle, which is a slower extrusion speed, letting this extruded gutta percha push the needle out of the canal to the orifice level. You can actually take the fat end of the plugger and cut off the surplus gutta percha at the orifice level, and then you're going to condense the gutta percha until it's firmly set at that point. It's a very three-dimensional fill. Carrier-based obturation was developed by Dr. Ben Johnson, the founder of Tulsa Dental Company. His concept was to place gutta percha on a metal or plastic rod, to heat this device in an oven, to push it into a shaped and cleaned root canal. The term carrier-based filling refers to the fact that the gutta percha and sealer are moved through the root canal system by the carrier, and as such, it is not supposed to fit the canal tightly, but loosely. The only clinical failures I've seen with carrier-based filling have occurred because of undershaped canal preps, causing binding of the carrier in the canal. The primary advantage of GT Obturators over Tulsa Dentsply's thermofill carriers is that they are placed into a preparation made by GT files, thereby ensuring the ideal but loose fit of the GT carrier in the canal. Because of this ideal fit, the GT Obturator technique of filling is more predictable and accurate, but must be done a bit differently than the thermofill technique. There is a GT Obturator for every file size in the GT system of instruments. Carrier-based obturation is quick in its placement in the canal, but it is a technique-sensitive method that requires careful following of critical guidelines. First, the carrier is measured 1 millimeter short of full canal length. This recommendation is made based on research done by Dr. Bob Sharp. These sagittal dissections show the typical 1 millimeter sealer and gutta percha front ahead of the carrier. When GT obturators are pushed to the full length of the canal, this material front is unnecessarily extruded past the terminus. While there is no clinical consequence with this small amount of surplus, on the button is even better. so I hold them 1 millimeter short. It's placed on the arm and hung by the handle of the carrier, not by the stop. We're going to use paper points to dry the canal, reconfirm length, and to apply the sealer. Next, and very important, blot the surplus sealer with successive paper points until one comes out of the canal spotted with sealer rather than coated with sealer. Start the oven. Wait 14 seconds to heat a small carrier and 35 seconds to heat a large carrier. When the oven beeps, the carrier is taken out of the oven and carefully placed into the canal. It is critical that the carrier be slowly taken to position over 6 to 7 seconds. If you place it too quickly, over 1 to 3 seconds, you'll have a lot of surplus. The carrier must be placed slow enough to allow the viscous gutta percha that is surplus to escape coronally rather than be forced apically. While my initial indications for use of GT Obturators were for the most difficult cases, I've since found they are an exceptional method to use when filling the simplest cases as well. I know that with the techniques I've shown here, you'll be amazed by the results yourself. You have seen two simple and efficient methods of three-dimensionally obturating root canal systems. As with all endodontic filling techniques, the success of filling root canals totally depends on the quality of the shaping and cleaning procedures that precede the fill. Without the correct shape in a root canal, it is impossible to adequately control the apical extent of filling. Without effective irrigation, it is impossible to fill lateral and accessory canals. However, if these critical prerequisites have been accomplished, the center condensation techniques I have shown you can fill the most complex root canal systems in seconds the first time you use them in your practice. Please log on to my website, endobuchanan.com, for information about our more detailed DVDs and for our hands-on training courses at Dental Education Laboratories. I really appreciate the time you spent watching this disc, and I hope it's demystified three-dimensional obturation with thermal-softened materials for you. In the meantime, I'll see you at the apex.